And here's a HalliCrafters model S-40B. This is a large shortwave receiver sold in the early 1950s. This was a mid-range set for those times. It sold for about $129, starting in 1950 and ran through 1954. I picked this up at a local ham fest. A lot of people in the shortwave listening and amateur radio community refer to these as boat anchors because they are very large and heavy. These radios were commonly used on the amateur bands for a receiver. Back in those days, they had a lot of setups were separate receivers and transmitters, and this would have been used for AM or CW reception, in addition to probably a transmitter on either mode. We have a tuning and a band spread, along with the off-on, high, medium, and low tones. There's supposed to be a pitch control here, but either that's been broken off or is adjustable from the inside. I'm not really sure. I believe this is broken off here. You have 4 bands, sensitivity, which is probably the equivalent to your RF gain, and your volume knob here. This set, I have already tested the transformer on this set and found it to be good, and upon applying power to the set, I found that there was no audio. I confirmed that the connection between the speaker and the headphone jack was good, and it wasn't, so I rebent the internal pin for this to contact the outer connection to make continuity across these headphone jacks to the speaker, and I immediately got a really low hum, so I know the connectivity, the continuity is good there. Anytime you're working with this old equipment and you turn it on and you don't get any audio on it, and if it has a headphone jack or some kind of external speaker jack, that's one of the first things I check when there's no audio condition, if there's continuity across these pins. A lot of times that's all it'll be. Those things lose their spring elasticity over the years, and sometimes you have to bend them back, and so they'll make continuity, or clean the contacts. A lot of times they'll get dirty. The top door on it flips up, as you can see, to reveal 8 tubes. This is an 8-tube set, obviously ran by a power transformer. You have your variable tuning capacitor along with your band spread tuning capacitor. You have, like I said, your 8 tubes. They're all 6.3 volt tubes, obviously, because it runs off a transformer. And here's a better view of the chassis with the rear cabinet removed. Like I said, 8 tubes. You've got 2 6S SK7s, a 6 SG7, 686. This is your burst audio tube and your final output audio tube, which drives the, your normal audio output transformer and goes to your headphone jack and into your speaker. These dials are backlit. The backlit bulbs do work. So what we're having here is a no audio condition. you plug it in and everything lights up, but there's just no audio coming out of the speaker. And here's the underside of the chassis. It pretty much looks all original, with a lot of the old paper caps in here, along with the famous Bumble Bomb capacitors that are in here. And of course they will all need to be replaced. And the first thing that got my attention was this large power resistor. It looks like it has had a meltdown. I did measure it. It is not open. It reads about 1500 ohms. I'm going to have to get a schematic and find out what value that is and replace that. That doesn't look too good, so we'll try and replace that resistor. We may end up having to order that one in. The rest of them all look just kind of aged. There's a 10 microfarad cap right here that looks like the wax is trying to come out of over here. But other than that, they don't look too bad. I don't see anything that looked like it was too bad. This wax looked like it was melting a little bit, but I'm going to go ahead and replace most of those capacitors anyway. And here's the set on. There's no sound coming from anywhere. I don't know if this mic will pick it up, but there's a real small hum coming from the speaker. That was after I fixed the continuity issue with the headphone jack. It's basically getting no audio. So I think the best point of way to attack this would be to use the signal tracer to try and trace the audio before the audio circuit, probably in the IF can area, and see if we get a signal. Okay, I'm going to start trying to trace the signal in the radio and see if we get a signal coming from this last audio, or excuse me, IF transformer right here. See if we get a signal right here. So we have a signal there, so we know it works there. Let's see if we have a signal. I'm going to jump a few steps here. Here is the output of the volume pot right here. We do have a signal there. So let's see if the output of the first audio tube is working here. This is the plate.
And so much more. Oh, plus we got Monster Truck Guy. Who knows this many value menu options?
Okay, we have a signal there. Okay, it's going across that cap. I just replaced that cap. That cap was not the problem, obviously. So what I want to do now is see if it's getting across the output, getting across this tube here. Oh yeah, we got a more than stout signal there. I'm going to reduce the volume.
WTAM 1100, home of the Cavaliers. We donation calves now on News Radio WTAM 1100, home of the Cavs.
What I want to do is take this, I want to take this wire off of this transformer here and see if we're see what's going on with this transformer. I've got a suspicion it's open. So I think we need to take the these leads off of here and check the ohms on that thing and see if it's open. And measuring our windings across our transformer, as we can see, it's wide open. And measuring our windings, this goes over to the speaker because that wire goes through to the speaker. We have about 4 ohms. So that the secondary winding is fine, but the primary winding is open. So we have a bad audio output transformer. Alright, so I removed the old transformer and installed this transformer that I had out of a junker radio. The primary winding on the old transformer was supposed to be, according to the schematic, 390 ohms, and the primary winding on this transformer here measures 425 ohms. The secondary winding on the original transformer was 4 ohms, and this one measures 4 ohms as well. So there's a little bit of a slight difference in ohms in this output transformer. So what I want to do is check. I'm going to turn it on and see if it works, and then what I want to do is check the bias on this tube here. Okay, we got it turned on. Yes, we do have audio.
We've heard from Maxine Waters this week about her desire to impeach.
And from your tenured opinion, what is it that the American people can really expect over the next 4 years out of President Trump?
Well,
he's not there for 4 years. I hope that
it works, but
what he's done, the way that he's defined himself,
it doesn't get super loud, and you can turn the volume up, and about 3/4 of the way up it sounds like it's kind of flat topping a little bit.
right into impeachment.
My greatest leader, right, and then Nancy Pelosi. Well, and once he breaks the law, yeah, of course we're going to move forward with impeachment.
Yeah, I'd say about the last 10% of it, it's starting getting distorted, and it's not very loud. So yeah, I think we need to check the bias on that tube and see if the impedance of that transformer on the primary winding has thrown off the bias of that tube, the 6K6 output tube. Okay, so what I've found with some basic voltage checks is on the audio output tube, we're getting about 17 volts of plate voltage. The voltage on this 680K resistor, which I changed from the original because the original was a little bit off anyway, is like 0.7 volts. This cap here, I changed it just in case it was shorted. I was going to change it anyway. Changed a few caps, no luck. So basically what we have here is coming in to from the transformer, we have about 280 volts coming in from the transformer, which is supposed to be closer to 380. We got it going down into this resistor here, which I took the filter capacitor and changed all these and put them on a terminal strip in case we had a shorted cap, which we don't. The filter cap in it actually was off, but it wasn't nowhere near shorted. The original power resistor, I changed it because it looks like this. This didn't happen, you know, just out of nowhere. I mean, this resistor is shortened, and when I put in the new 1500 ohm 10 watt resistor, we're getting the same thing. This thing is heating up way too hot, and so that tells me we have a short somewhere in this line. I'll show you some voltages here and show you what's going on. Okay, we have it playing. You know, the volume's up pretty good ways, so we're hardly getting any volume. We're getting 269 volts on this pin. It should be around 380. Going into the resistor here, the same amount. Coming out of the resistor right here, we're only getting 17 volts. So we've got a short somewhere in this line here, or somewhere in this line. This resistor is getting really hot. So I've already went down here and checked. This is the plate voltage we're getting. We're getting 16 volts plate voltage. That should be 240 or something like that. This pin here, 15 volts. Should be more like 200. I'm getting 0.6 volts. I should be getting 22 volts on that line. So we've got a major short here. Okay, what I've found is, coming from our resistor here, if I can get the camera oriented right, we've got a line, a red power line here, and that runs up here to this IF can, which is not getting hot. Then there's a jumper wire that goes further up the line to here, which is not in series with this cap. Then that jumps over up to here. Well, look at what we have here. We have a bulging, what looks like a mica mold cap, or I don't know if this is it looks like a mica cap, but it could be one of those paper. It could be one of those mica mold caps. It's real prone to going out, but we have a split bulging capacitor here. This is very highly suspect, especially being in the line with this power resistor. A little bit further up the chain here, this line goes into here, which is in the coil and ends up going up to here. So we need to check and see what's going on here. I believe this is our problem here. Okay, we have our capacitor disconnected, which I believe is completely shorted. Let's verify that. I believe this is shunted to a ground or something like that, but we're going to find out. Let's put our little clip on there. Yeah, that thing's acting more like a resistor than anything. 109.6 ohms. Probably being shunted straight to a ground. It has no capacitance to it at all. It's completely open. Yeah, that's gone. There's something up with that. I'm gonna have to see what value that cap is. We'll have to get a replacement for it. But I'm gonna fire it up and check it with it out of the circuit. Oh yeah, that's a whole lot louder. That's a whole lot louder. Let's do some voltage checks here. Okay, so this is our incoming transformer winding voltage. Let's turn it over to DC volts, dummy. Oh yeah, 352 volts. That's picked way up. Now, coming out of our resistor, which is right here. Sorry about spinning you around here. 270 volts. That's a whole lot better. Boy, that thing had that thing completely shorted out. Let's check our plate voltage on our 6K6 tube. 261 volts. We were getting what, 17 volts before? Let's check our bias here. That's back up to 16 volts. That looks a whole lot better. 236 volts on the grid right here. What is that, pin 3 or something like that? I can't really tell right now, but yeah, our voltage was like 16. We're getting 235 volts there. That looks a whole lot better. I think that one's rated at about 240 volts, 235 is close enough. Yeah, I think we're definitely back in business now. We found our main shorted culprit. I barely have the volume cracked. So we need to find out what capacitance that capacitor is up there and get that one replaced. May want to go through and check all the other ones that's still in there. Okay, we have our 22 picofarad capacitor replaced in the tank circuit in here, and looks like we went ahead and replaced all the other capacitors. All the old paper caps, got those done, and I'm gonna have to go through and do a little more thorough resistor check. I haven't done that yet. I did go through and check when I was troubleshooting to see if there was anything shorted or open. Usually resistors don't short, so I didn't really check too many, but I did check a lot of the voltages and stuff down here in the audio circuit, because I was thinking that was where it was at. I still got to put a safety cap in here. I haven't done that yet, but yeah, for the most part we're playing really good and everything seems normal now. So it was just that shorted cap there. Everything else looks pretty good. I think the next order of business is going to be to go ahead and get this tuning string here, which is very loose and slipping. You know how much I love to mess with dial cords. Well, this one's going to have to be redone because it's loose and everything else. I'm going to have to tighten it up and see if that'll take care of it. If not, I may have to put a new band spread dial string on there. The main tuning capacitor seems okay, but this band spread setup is really slipping, and it's pretty important when you're trying to tune in fine tuning stuff on the bands, especially like in the amateur bands. When you're doing sideband listening and so forth, it's a lot easier to go ahead and use the band spread on it. As I said, the cord's slipping on it, so in order to do that, I'm going to have to pull this front cover off, which I'm not sure how easy that is, but it's going to have to be pulled off to get to it, to access everything. And while I'm in there, I might as well clean up all the all the dials and the bulbs, and clean this dial glass and all that while I'm in there and get that looking better. And eventually, since this chassis is so open, I'm going to pull all the tubes out and do a little cleanup on the chassis in here. It's quite dusty, as you can see. Do a little cleaning up on our tuning capacitor and get our band spread and all that set a lot better, and then do an alignment on it. I'm going to have to check the resistors, you know, of course, but haven't gotten around to that yet, but we will get to it. So with this band spread here, I've got that fixed. Got the string all redone on it, tightened back up, and got this thing, the pointer fairly aligned here. So we got that working. And I got all the dials cleaned up along with the face. The bulbs cleaned off. And so the next thing we want to do is try to get this pitch control here done. The shaft has broke off about flush with this inductor here, and I've already taken it loose from back here behind, and I've already taken this out and tried to work it out from the back here up, and apparently this threads into here, so I'm gonna have to drill a hole down in here in this main shaft here in the center. Try to drill a small hole in there and see if I can tap this out. See if I can get this thing to back out or whatever. I guess the best thing to do would be to screw it in and try and get the slug out of the back here. Not real sure how I'm going to do this, but I'll see if I can figure this out. Probably going to have to end up trying to extract this ferrite core in the middle of here and see if I can attach a new shaft or figure out what I'm going to do to get that adjustment back there. Okay, I got the old and got the inductor apart. I got the old thing out, the brass screw that ran through the center of this, and this has been rebuilt here. The thing is the original inductor core, which is here, is fused to the shaft, and you can't get it off without breaking it. I made the mistake of trying to take it off, and so we I broke this. I tried to glue it back together because ferrite is pretty porous and actually takes pretty well to super glue, but you know, I did put it back together to get a size of it. Kind of got this one pretty close. This is another slug out of another radio, and I was able to drill a hole in the center of it. If you breathe on this stuff the wrong way, it'll break. It's very brittle. So anyway, I was able to tap this one out enough, as it already had a hole in the center of it, so I just made the hole bigger. That made it a little bit easier. Now, this thing being steel, I think it could be a problem with the inductance. The original being brass probably made a difference on the inductance. So if this becomes a problem, I'll have to end up buying a brass screw to replace this with. But basically, this is just a regular standard screw, and I just cut the head off of it and threaded this core, drilled a hole slightly smaller than that, and was able to cut it into the threads on this screw. Now if this doesn't work, I should be able to remove this core fairly easily, and then I'll just have to replace it with a brass screw. But we're going to try this and see how this works out. Now here's the shaft slid in here. There's 2 pins on each side that you take out to disassemble this. You'll want to take this apart somewhere where if these pop out you won't lose them. But they just press in here. On each side there's a hole, and those little pins just press in here. Okay, I got this thing back together and it seems to be working. We got our pitch control knob. I had to put a random just universal knob on it. And it's got the set screw. You have to lock it down. It seems to work okay. Now I want to point out something about this radio and how to get the front faceplate off. Basically, you know, you're going to pull all your knobs off so it'll slide off. But the main thing all that really holds this thing on here are these switches. Once you remove the nuts on these switches here, the nut for the standby switch and the headphone jack, when you have your knobs off, it should just slide straight off. So I've got this thing working. It seems to work okay. I'm gonna have to go through and check resistors and stuff like that, but for the most part it seems to be working okay. I'm on the 20-meter amateur band here. It takes a little work on this thing to get sideband tuned in on it, being it's a CW set. It's not specifically for upper and lower sideband, but you can tune in people on here with a little effort. So the easiest way I found to do this is to park the main frequency dial here, your main tuning VFO dial. Tune it to the top end of the band you wanna listen to, and you use your band spread to tune downwards. You're going down on the dial, but a lot slower. Now it's really easy to overload the front end on this radio, so that's what this automatic volume control ABC switch is for. You flip that on and it's going to really desensitize the receive, but it's going to keep strong stations from overloading the front end of this thing and really distorting. Okay, I'm going to check the tubes on this thing. I just got done replacing the resistors on it, so I figured I'd move into checking the tubes here. So this is the 6K6 audio output tube. It's in the question mark area, a little weak. So let's see what we can do, see if I can find one maybe a little stronger. This one's been played on the radio and it's pretty hot, so it's probably a little on the weak side here. Okay, I found a little bit stronger one here. This one reading about 67, 68, so that's a little bit better. We'll go with this one here. Alright, so this is a 6SC7, which is the first audio tube. It's about 50, 55, a little on the weak side, but still creeping up into the green. I don't have one of these, so we're just going to have to leave it be for now until I can get maybe one a little stronger. Some of these things read a little finicky on these tube testers. See, it's moved up into the green. I may recheck this one on my other tester and see what it says. But I think for now we'll keep this one. And here we have the GM Genuine Parts 6 SK7 tube. But you couldn't get that part anymore from GM. Coming in at a whopping 75 or 6%. Pretty good strong tube there. Here's the Kenrad 6K7. Coming in at about 62 or so. That last tube I checked, the GM one, I had this off a little bit, so it read about the same. So these are still good though. So here we have another Kenrad 6 SG7. This one checks pretty good. It's barely in the green. Okay, we have this RCA 6SA7. Just in the green, just a little bit, about 58 or so, 57, 58. And here we have a, looks like an old military 686. It's the VT90. Which is coming in plenty strong at 73. That's the diode 1, diode 2, is pin 5. That one coming in a little over 70. Well within the green. Good tube. Okay, I got everything resistor wise done. I've got this coil of wire in here for the signal generator, and as you can hear, there's a tone. And we're getting ready to do the alignment on it. That one's off a little bit. Okay, I got it all back together and playing. Everything seems to be working okay. Seems to work pretty good. I'm on 40 meter lower sideband here.
Tango India 2 Tango Lima. Good evening, W2PTH 58 in Southern New Jersey. We have a full Sierra Tango uniform. And Cherry Hill, New Jersey is located right across the river from Philadelphia, Pennsylvania. Thanks for the call. I've been calling for a few minutes, and you're the first reply. TI2.
Got a nice bassy sound to it.
sometimes, and even then it's not good. I mean, it's not, it isn't like it used to be. Well, then I call Ron RSS on the phone, and he updates me. Yeah, okay. He tells the truth, doesn't he? He does mostly. He's a little biased towards Ford Motor Company, but that's okay. Yeah, the damn dog that he's got that he doesn't feed. He talked me into buying a really nice, brand new, out of the box with that new car smell Ford Explorer the other day, and I love it. It's got that new white smell. Yes.
Sounds like a little GT65. Okay, let's see if we can jump up a little bit further up on the dial here. I always try to set this back to 0. See if we got anything going on 20. Code. Alright, well, I showed you the sideband, so we'll tune around.
Yo creo que todos los municipios, en cada uno de ellos, los que han estudiado.
WWV. It's going to be off a little bit because I have the band spread. It's dead on 15 there.
Craig Mack's right where he's supposed to be. About to erupt. Mack's a warrior.
Let's try band 4. That'd be the upper scale. Not much on here right now. Yeah, it's getting kind of late. I think this lower bands are the ones that are propagating right now.
De todo el tiempo que Escúchese. Este es el más especial.
La libre masculina. El 22.
Okay, we'll go to band number 1, which is the AM broadcast band on the bottom.
It was great. The whole thing was like that. Candidate Trump back to safety.
Escape debris burns are the #1 cause of wildfires in South Carolina.
Really easy to overload the front end of this radio.
The father's name was Omri, who claimed to have wrought evil in the eyes of the Lord.
That's a station about a mile away, so it's overloading the front end. Turn the sensitivity back up, so that help out here on the lower end of the band. Alright, so there's my 1950 HalliCrafters Model S-40B. Just about a complete electronics restore. Here's the pile of old components. Alright, thanks for watching.